Since the last explanation video did not help much, I've decided to record this video where I will build everything from scratch so you can see the process of building and operation at the same time. As you can see, I have my mod loaded here, and expanded matter, it's here simply because I tweaked some recipes there. It's not needed by my mod, you can ignore it. So let us create new world in creative, some random name, and I will probably cut the video till the world will generate. So here we are inside an empty world, as you can see, and now we shall begin the construction process. First of all, here are all the blocks that my mod has, and we shall begin with blast furnace block. Okay, so you can see on my hotbar there is refractory bricks tier 3. Rather there are blast furnace door, molten metal tap, to air, gas outlet, bell hopper, reinforced hopper, and large red bricks. Large red bricks I will use as a foundation to separate everything. We will see it later. Now, we need to rise our building up. Rise it up. Probably to this height. How many blocks are there? 1, 2, 3. No, probably even one more. Even one more. So, here you can see all the blocks, all the positions of the blocks that are needed. Now I will first fill everything with refractory bricks. So, as you can see, all of the projection is filled with refractory bricks, but the chat readout tells us that there are functional blocks missing. Let's put them inside the structure itself. Here are the blocks that I need to remove, and actually these blocks are not needed as well. So, gas outlets go here. I remind you that they are used to expel the gas, so that's why they are up here. Down there, we need to put 2 airs. 1, 2. These are used to supply the blast furnace with hot blast. Here we need to place molten tap for our slag, and here we need to place molten tap for our molten iron. Then in the top we need to place first bell hopper, then reinforced hopper. Now the build should be completed. Yeah, it automatically detects it. You can remove the projection by control right click. Now it says, as you can see, blast mix loaded, blast furnace needs blast mix to fire, and so on. We can look inside. Here are the hoppers. Here is the main shaft. All of this should be filled with blast mix using the hoppers, but you probably have seen that already in the previous video. Or if you didn't see it, then you should probably watch it. Now, to actually fire it, we need to wire up all of the piping, because, as I said, blast furnace requires exhaust to go somewhere and hot blast to be provided. To do this, I need piping, a lot of pipes. We have straight pipes, we have bands, T-junctions, X-junctions, I probably won't need those. I need valves, pressure valves, I need lowers, gas intake, and I probably need, let me remove this for now, and we probably need the copper stove intake and heat sink and now this is enough. So, first of all, we need to connect all of the piping into single network. By this, I mean we need to place it right here. Let me get a wrench. You can use a wrench to rotate these blocks. Now, this T-junction merges this pipe and this pipe into a singular pipe, which is easier to manage. We should do the same thing for the upper one. Okay, now we have two pipes. This one is for hot blast, this one is for hot exhaust. Both of these things should go into copper stoves. I remind you, we need two of them. So let us build them. First, I need to understand the orientation, probably like this. Yes, and we need 3x3 foundation for those. Let me fill this up. Now we have two foundations. First things first, we need to place our gas intake, which is the main block over here. Then we need to remove all of this because I miscalculated. Then we need to place another one here for the second one, and need to take a refractory brick. I will first construct a refractory brick shell and then fill everything up with structural rocks. Also, you can show the projection like this as well. So now we have two copper stoves, outer shells ready. Now we need to place the functional blocks. First, iron hatch doors on this side and on this side. Then heat sink, which will store the excess heat. 4 of those inside in both stoves. Now we need to cap it off with a refractory brick block and fill it with outlets. First outlet is here. This one serves as a path-through for exhaust, so our exhaust goes in through this block and goes out through this block. Then we have another input block as gas path-through like this. Here the blast, cold blast, will enter the preheated gas copper stove, and through this gas outlet, like this, it will go out and into the furnace. As you can see, this is exactly why I put it into this elevation, because now this outlet and this pipe is on the same level. Most of them are on the same level, so it will be easier to connect. Let me fill this one like the same. So now, as you can see, both of the copper stoves are finished and they show idle state because nothing goes inside of them. And now we need to connect all of our piping. This pipe is for hot exhaust, so we need to route it down to this input intake, or I should say. To do this, I really need to go out one block, so it will be easier. Yes, I should do it like this. Then it will go down, and it will level out. Now, T-junction. here we need to put our valves. Valves are used to manage copper stoves. You need to operate them to switch their operational status. So you don't need to do anything with the structure itself, you operate valves. These valves toggle the hot exhaust intake. So when these are open, the stoves will heat up. When they are closed, stoves cannot heat up because they don't accept any gas, any hot exhaust. Now we have this pipe. It should connect to these outlets because these outlets will carry our heated blast to the furnace. Let us do just that. Here we don't need any valves, so I can just connect it like this. Actually, we don't need a D-junction here, it should be like this. I should disable the projection, by the way. So, now we have hot chilled exhaust outlets here. So the exhaust will come through this pipe and go out from this outlet. We need to connect it up into this single pipe network as well. Here it goes. So here is chilled exhaust, here is hot exhaust. We need to merge both of those into the same network so it can go into the smokestack. To do this, we need to use a separator because the networks with different temperatures will just average out and your copper stoves will not be able to heat up. So we need to use this pressure valve, which will separate physically this network and this network. So even if some gas overflows through this pressure valve, it will go just into the smokestack. But at first it will always go to the copper stoves and give off its heat. Now let me connect everything. We need to add this connection. And place T-junction here. Or we can do T-junction here for some unknown reason. Anyway, this is the pipe that will carry our processed or our exhaust, and we need to deal with it. To deal with it, we have our smokestack block. You can place it like this, spawn the projection, and you need to fill everything with fire clay bricks, as you can see in the chat readout. So I will do just that. So, the last piece of the puzzle, we need to supply these copper stoves with cold blast through these pass-through blocks. To do this, we need pipes here, or rather valves, so we can manage it. When you open a valve, or rather when you open a valve, which does bug probably. Anyway, when you open a valve, you allow the flow of the blast into the copper stove, so it starts to heat it up instead of the exhaust. If you leave both of the valves open, so you allow both blast and exhaust to mix inside the copper stove, nothing happens. It cannot heat and then cannot discharge. It simply will sit there doing nothing. So be careful. Always close one of these valves. I've placed a gas blower and a gas intake block. Basically, this block allows the open air to enter the gas network, and this block pressurizes that air into blast. But it doesn't do it by itself, it requires mechanical power, as you can see by this small axle outlet on the both sides of it. So, we need a source of mechanical power. Now I will use a water wheel as the source of the power, because that is most likely what you will have access in the survival world, and that is what is the most probable source anyway, because you need stable power output for this to function. If suddenly, for example, if you will use windmills, then if suddenly wind goes out, your blowers won't work, your copper stoves won't work, your blast furnace will extinguish, and you will lose almost all of your iron inside. So be careful, it's probably better to use stable power sources here. So now we have the water wheel, powers one large gear, that powers another large gear to achieve this much this rotational speed. Now the blowers are blowing. You can see here that this pipe has blast, so it's pressurized. And now if I open this valve, for example, you can see that this pipe also will have blast, because it will go straight to the through the copper stove and into the furnace. But again, this blast is of ambient temperature, 27 degrees Celsius, which is not hot. Now we have everything in terms of piping that we need to operate the blast furnace. Let us add the required molten canal nut. I think I have everything in my inventory, so we can start constructing this. First, you place molten canal start block. This is where your molten network starts. Now you need to place a straight block, or you can just ignore it. Now I will use this as a foundation and place top, which will allow you to drain slag. I remind you, this tap is used to drain molten slag from the blast furnace. So, and this is here. This is where you need to place your molten barrels. So the slag will drain safely into the barrel and it will not clog the furnace itself. Now on the other side, now that we have some sort of foundation, let us place a start block, then straight block, then a T-junction, then another straight block, then T-junction, T-junction, and top block that will allow us to accumulate excess iron. This is where the iron will go, and we will use this barrel to drain the network of excess iron, so it will not solidify and clog it. And now we add this. These are molten pedestals where you can place all the molds you need. These pedestals accept any vanilla mold. These molten pedestals accept any vanilla mold or any mold that is added to the vanilla file, like my molds do. So I simply need to search mold and take whatever I like more. For example, I can take this one, and let's pick one of mine, for example, double ingot mold. You can place them down like this. Oh, by the way, you will need a lot of space, so you will be able to place these molds to cool down, because when they are filled with iron, you will need to place them somewhere so they will be able to cool, and you will be able to take your resulting items and materials. Now, this is enough to produce iron materials. This should work, and we will test it later. Now I will add the steel line. So, as you can see by this foundation, the Bessemer converter will take 3 by 3 by 3 space. First you will need to place a transmission block, then a controller block, and on the other side, you will need a gas intake. The converter itself sits between these blocks, and to spawn it you need to use the controller block. Since I'm in creative, I can do this without materials, but if you are in survival, you will need to supply it with what it says right here. So I click with the right mouse button, then I advance the construction until it's complete. Now the Bessemer converter is ready. As you can see, it's positioned like this. It will drain the molten iron from this canal, and it will output the molten steel into this canal. So this is where your steel line will go. Now, as you can see, the converter says that everything is fine. It recognizes that multi-block structure is complete. It's both a multi-block structure and right-click buildable, by the way. So everything that is built with red bricks is not necessary. It is not a part of a multi-block structure. You can decorate or build some sort of support structure however you want. Anyway, this is the iron input, this is steel output, but also Bessemer converter requires mechanical power input and a blast input, since it blows the blast through molten iron to cook it into the steel that we need. So let me build some sort of contraption that will power all of this. So the build is complete. I've added these molten ground setup is the same as the iron, no changes there, and I've routed fast axle and slow axle to power the blower and the Bessemer converter itself respectively. Again, the converter is a massive structure, as you can see. It requires some power to operate, so if you route the high-speed axle, it will probably not have enough torque to rotate the converter itself. So be aware of that. But we need speed for gas blower. And as you can see, this is exactly why I put the blast furnace and everything else at elevation, because the molten iron or molten metal rather can go only down, so you need some vertical space. And since you need to route all of these power connections and pipes and so on, all of this setup probably will require you to build a whole steelworks plant of some sort, an actual plant that will house all of these structures and will actually allow you to comfortably operate valves, operate taps, and replace, store a lot of molds, go between levels and so on. Because right now I'm flying because I'm creative, but in survival you will need some sort of structure that will allow you to go around and operate the machines. But now everything should be complete, so let us test this. First, as always, we need to load our hoppers. First I will take out crushed iron, here it is, crushed coke, and limestone as the flux. Lime, I said. We can load it in. And if you look into handbook and browse through advanced steelmaking guide, you can see that the blast furnace will consume, I put the recipes here. I can see it from the plans, but it's somewhere in here. The blast furnace will consume 12 iron per 3 coke and 1 flux. So the iron will go out fast, the coke will go out moderately, and flux will go out slow. This is probably the resource you need to worry about and prepare a lot of. Now I need to enable the dropping of the blast mix inside of the furnace shaft. I can resume time, so particle effects will go as well, and I will probably help the copper fill all of this because it will do it not fast enough for me. And now I probably don't help but rather waste some materials. Anyway, now as you can see, blast furnace has a lot of blast mix, and 320 units is how much you need for it to fire. Now we need to light it up, or to light up we need to use a torch. Now we will wait for it to fire. Also, while it does that, we can make a makeshift valves using fire clay on these blocks. For example, fire clay. I cannot type today. So here is some fire clay. I can use right click to apply these blockages, and this way the canal becomes unavailable for the molten metal to traverse. So the metal will not go to this steel conversion process. At first we will make some iron materials, and to that let us prepare our molds. At first I will leave the barrel tap closed, but if there are some iron left, you can always open it to drain the network. Now we will need to simply wait when the furnace lights up. Now the furnace started firing. You can see the internal temperature rises slowly, and the pipes started carrying exhaust. We need to allow the exhaust to pass into these pipes. This is probably a bug I need to fix at some point. So the exhaust will go out through this outlet into the smokestack, and it will heat up the internal heat sinks of the copper stoves. At first, this process will go really slow. To speed it up, we can use andesite. Simply place a stack here, and you light them. This way you create additional hot air flow that allows to better process the incoming exhaust, so it will heat up faster. The anthracite itself does not heat up copper stoves, it simply makes them heat up faster. So as you can see, the process goes up faster. Now we simply need to wait for stoves to heat up and for furnace to heat up as well. By the way, while the copper stoves, both of them heat up, as you can see there is no airflow here in this pipe, and the blast furnace doesn't receive any blast. This is normal. This is simply because both of the stoves work off the exhaust to accumulate temperature. When one of them will heat up to acceptable level, we will start producing hot blast. Now, the blast furnace has reached its maximum internal temperature in this mode, and the coppers already reached 800 Celsius. 800 is the temperature you need for the blast to actually work inside the blast furnace. So we need gas at 800 blast temperature. Right now we can start supplying it for a while, but let's do this. We need to switch this valve so it will some maneuvers to cut off the input of exhaust, and open this valve so the blower can start blowing the blast inside the heated stove. Now you can see that the blast of 800 degrees Celsius started going down this pipe, and the blast furnace started to heat up to the temperature of iron melting. Again, I reduced the time required for the melting to start. At normal configuration, it will take around 5 minutes for the melting process to complete. Okay, the furnace started making iron. In this mode, it will produce 60 iron per 10 seconds and 10 molten slag for 10 seconds. As you can see, the slag started going to the barrel, and the iron is accumulated inside the furnace because we didn't open this tab. Let us accumulate some iron before we do that. And the blast has reached the temperature that we can use it. So let's start switching the stoves. Again, I'm in creative and I can fly around and reach these valves. If you are in survival, you will need to run around all this. So be sure that the valves are in the places you can actually comfortably reach. Okay, we have some iron. So let us start pouring. Have a look on this step, and the iron starts flowing down the canal. This is, by the way, a new change. I've changed how the canals work. Now they actually carry molten iron in themselves and simulate the flow. Before they were simply traveling instantly. The iron was traveling instantly. This mold is ready. You can pick it up. By the way, I also fixed the rendering enhance. You can place it down, and I hope it's probably will shatter because we have rain right now. This is solvable. You simply need to have cover overhead, but I hope again you will have cover when working with this. Now let me close this tab, since this mold is ready as well. We can place it here. Let us drain iron into another mold. Hope it has enough. As you can see, iron actually flows and tries to stabilize. Now we have another full mold, and the rest of the iron should go into the barrel so we can drain it safely. The blast is still has required temperature, so everything good. Now let's wait for the iron to go into the barrel so I can open this canal and we can start making steel. Okay, all the iron is cleared. Now we can open up this tap again, and it should go straight down. If it goes right here, we can again close it, allow it to drain again, and you'll need to seal this using fire clay. Keep an eye on the temperature of the blast. I probably need to switch stoves. There is some iron left over here, but what you can do is molten iron. Now we have sealed this route, and we can allow the iron to go here. It will start going this route this time, and we need to set the Bessemer converter into the filling configuration so the iron will go straight into it. As you can see, it started accumulating charge. make sure that there is a blast on this side. Yes, there is. Also, you need one blower per converter and one blower per copper stone. One blower cannot support two structures. So the iron flows rather beautifully. Pink, tasty. By the way, I am a creative, so I am not getting hurt. But in survival, you will get hurt if you stand on this, and you will get hurt if you pick this up without hand protection. But our iron items are ready, and pick up our pickaxe head. So everything works as expected. Taking a little place. Now the converter is almost full. I will let it fall like this. Let it complete. Fill it up everything. Yeah, good. Now, converter has almost 1000 of steel, and as you can see, the temperature is dropping. Let us set it to normal configuration, so the Bessemer process will start. It will keep the iron at the 1600 degrees level, because the Bessemer process is exothermal, so while the iron, or rather carbon, is burning inside the iron content, it will keep its temperature. But when the process will complete, the temperature will start dropping again. Here it goes. We have steel. Now we need to put it into boring configuration like this, and the molten steel started flowing. Let me put some molds here, so it will start filling. It's solidified. Again, blasted the rain, but we were able to pour one full mold, and we can clear out this using chisel. I probably need to use it as a hammer. Yeah, it is too cold. Blasted rain. What you can do? As you can see, the temperature side of the copper, rather plasma converter is dropped already, and we weren't able to pour everything out. So, again, be ready for this. If this happens, let me go into survival. Let me get a pickaxe, steel pickaxe to be precise, and go in survival. We will be able to break this, and most of the materials required for building will drop, as well as the iron content in form of bits. But again, you will need to rebuild all of this. So, what can I say? Build a protection overhead. Don't fill up the basement converter too much, so it won't simply solidify when you start pouring, and simply wait for your molds to cool. Right now it doesn't shatter. I guess we are lucky. By the way, while I were explaining the steel production, the blast furnace extinguished because we ran out of materials. Basically, here is all of the slag that is left. We can break it, and here we have some solidified iron. You can see the iron bits amount on the top. If you break these blocks, you recover these iron bits, so you can pour them back into the furnace and smelt. Right now the steel should have hardened. take out our ceiling. So this is a full chain from nothing to steel production. Hope this helps listener.